Or in 6th grade, welcome to lesson 8 in math class. Hopefully you just got done with your fact practice and quiz on the back side. You are back to Power Up A. I'm not going to read the answers to you. I'll only read the answers the first time that you guys work your way through a Power Up so that you know you have the correct answers and then you can practice those things. But I would like to work the challenge problem with you today. It reads like this. The numbers 325 contains the digits 2, 3, and 5. These three digits can be ordered in other ways to make different numbers. Each order is called a permutation. We're going to use that word a lot this year as we continue to move on. Of the three digits, the smallest permutation is 2, 3, 5. How many permutation of the three digits are possible? Which is the greatest permutation of 2, 3, and 5? So I took the numbers 325, 2, 3, 5, doesn't matter, and we're going to make permutations. It says how many different ways can I rearrange this order. So you have 2, 3, 5. The next thing I do is I keep the first one the same and I switch the next two. So the next number is 253. Then I'm going to just work my way up. So now I'm going to put 3 in the front. And I have left 3, 2, 5. And then I have 3, 5, 2. Last one I need to do is put the 5 in the front. So I have 5, 2, 3, and 5, 3, 2. So if I move that down a little bit so you can see that, you have a total of 6 permutations. Now, how do I know that 6 is the right answer and I didn't forget one or miss one? This is how I do it. I was given a 3-digit number. So I take 3, and then you just count down and you multiply. 3 times 2 times 1. And 3 times 2 times 1 is 6, so I need 6 answers. Now, the second question they asked me is, what's the biggest answer you could get? 532. In the future, they'll ask you, how many permutations can you get from 4 numbers? Well, I could do this, rearrange them all, but if they just ask me how many, it's 4 times 3 times 2 times 1. So I will get 24 different orders. So in the future, when they ask you more numbers, they're not going to ask you to list them all. They'll simply say how many are there. It's just a math problem. That's how you find multiplications. Number of digits, write down the list multiplying those things. Okay, lesson 8 today, guys. We're talking about fractions, percents, and the inch ruler. Hopefully you have your yellow folder out, ready to rock and roll. And your math book now is open to page 54, and we'll get rolling on it as we get moving. It says this: fractions and percents are commonly used to name parts of a whole or parts of a group. And I have that written for you into your notes there. At the right, you will use a whole circle to represent one whole. The circle is then divided into 4 equal parts with 1 part shaded. 1/4 of the circle is shaded, and therefore 3/4 of the circle is not shaded. Since the whole circle also represents 100% of a circle, we may divide 100% by 4 to find the percent of a circle that is shaded. I take 100, I divide it by 4, and I get 25%. So key takeaway there, hopefully you know that, but 100%. Anytime you hear the word percent, you got to think of the number 100. If we find that 75% of the circle is shaded, we do subtraction, so that 75, I said 75, sorry. If 25% of the circle is shaded, we subtract from 100, so that 75% of the circle is not shaded. A common fraction is written with 2 numbers and a division bar. The number below the bar is the denominator. It shows how many equal parts are in the whole. Keyword, equal parts. We got to make sure those things are equal. We'll talk about that coming up. The number above the numerator shows how many parts have been selected. So numerator on top, denominator on the bottom. You got your first fill in the blank, shows the number of equal parts. I make sure to stress that. A percent describes a whole as though there were 100 parts, even though the whole may not actually contain 100 parts. Thus, the denominator of a percent is always 100. So 25% means 25 over 100. That'll teach us how to switch percents to fractions. A mixed number, such as 2 3/4, includes an integer and a fraction. The shaded circle below shows that 2 3/4 means 2 wholes plus 3/4. To read a mixed number, we first say the integer, and then we say and then we say the fraction. So that's 2 and 3/4. It is possible to have a percent greater than 100. When we write 2 3/4 as a percent, we would write 275%. They ask you, how do you write 3 1/4 as a percent? Well, they told us above that 1/4 is 25%. 3 wholes would be 300, so it's 325%. A, name the shaded part of the circle as a fraction and then as a percent. So the first thing I do is count how many pieces there are. 1, 2, 3, 4, 5. That's my denominator. Then I count how many are shaded because that's what they asked me, and that's my numerator, so I have 2/5. Sometimes we go, how many are shaded? 1, 2. How many are not shaded? 1, 2, 3, and we write down 2/3. Nope, total parts on the bottom, that's my denominator. How many they ask me on the top? 2. Okay, now they want me to switch that to percent. And remember, we always know percent equals 100. So one thing you can do is you can take 100, you can divide it by 5. 5 goes into 10, 2, 5 goes into 0, 0. And then multiply your numerator. So I like to say divide by your denominator, multiply by your numerator. And 2 times 20 equals 40. And 2/5 equals 40%. In your yellow folder, guys, halfway through toward the back, they have a chart. I don't know how easy you can see those things, but these are the things you're going to start to work on this year, just memorizing those. Fifths count by 20%, tens count by 10%, fours count by 25%, so we can do those conversions very easily. Number 2, it says which of the following could describe the part of the rectangle that is shaded? My choices are 1/2, 40%, or 60%. So what they want you to know here is if this was 1/2, it would go right through here, and 1/2 equals 50%. Well, more than 50% is shaded, so it has to be the correct answer of 60%. So I'm learning to look and say less than half would have been 40, half would have been 50% or half, obviously, so my answer has to be 60%. Continuing on, it says between the points on a number line that represent integers are many points that represent fractions and mixed numbers. To identify the fraction or mixed number associated with a point on a number line, it is first necessary to discover the number of segments into which each length has been divided. Example 3, point A represents what mixed number on the number line? So here's what you're doing, guys. The first thing you're going to do is you're going to count spaces between it. So 1 space, 2 space, 3 space, 4 space, 5 space. It's divided into fifths. Now I turn around and I count tick marks. 1 tick mark, 2 tick mark. So it is 2 divided by 5. Lots of times 6th graders for the denominator will count tick marks. You go 1, 2, 3, 4 and call it 2/4. Nope, spaces between the ticks and then where it is. Then don't forget your whole number. This is 8 2/5. A lot of times 6th graders will write down the answer of 2/5. Make sure you get that whole number that goes along with that. Turning the page, we got the second part of our lesson today, and that's the inch ruler. I forgot to highlight your yellow folder. Hopefully you got it. Mixed number, whole number, which we call an integer because they can be negative sometimes, and a fraction. Page 56. A ruler is a practical application of a number line. The units on a ruler are a standard length and are often divided successively in half. That means they keep getting chopped in halves and halves. That is, inches are divided into half to show half inches. Then halves are divided again to show 1/4 inch. And the division may continue to show 8ths, 16ths, 32nds, 64ths. In this book, we will practice measuring and drawing segments to the nearest 16th of an inch. That's standard. If I pull out a tape measure, it's divided to 16th. Your ruler, divide into 16th. It can get more precise, but not usually. Here we show a magnified view of an inch ruler with divisions to 1/16th of an inch. Guys, I would somehow in my yellow folder put this fraction ruler down. Page 56 is a great resource. They'll give you that a lot. We're going to get this coming up in an example here when we put these in order. But they'll also give you that inch ruler as a pattern. So if I look at that 1/16th, 1/8, 3/16, 1/4, sometimes we don't see what the pattern is and we get confused. That's actually going up by 16ths of an inch, but they're reducing those fractions. So if I would unreduce it, it would go 1/16th, 1/8 is actually 2/16. So it would be 1/16th, 2/16th, 3/16th, 4/16th, that reduces. 5/16, 6/16, it reduces, and so they're just trying to show you that. So if you're not good at reducing fractions yet, because we haven't had that lesson, feel free to put a little note in your yellow folder, page 56, really good to reduce the 16ths. Continuing on, bear in mind that all measurements are approximate. The quality of a measurement depends upon many conditions, including the care taken in performing the measurement and the precision of the measuring instrument. The finer the gradation are on the instrument, the more precise the measurement can be. That means the finer we break it down. Did we stop at 4ths? Did we stop at 8ths? Did we stop at 16ths? Did we go to 32nds? That's the gradation. For example, if we measure segment A, B, and C, D below with an undivided inch ruler, we could describe both segments as being about 3 inches long. We can say that the measure of each segment is 3 inches plus or minus to the 1/2 inch, which means each segment is within a 1/2 inch of being close to 3 inches long. In fact, for any measuring instrument, The greatest possible error due to the instrument is half of the unit that marks the instrument. We can improve the precision of measurement and reduce the possible error by using an instrument with smaller units. Below we use a ruler divided into quarter inches. We see that AB is about 3 1/4 and CD is about 2 3/4. These measures are precise to the nearest quarter of an inch. The greatest possible error due to the measuring instrument is 1/8 of an inch, which is half of the units being used. Half up or half down, or eighth up or eighth down. Example 4 says use an inch ruler to find AB, BC, and then AC to the nearest 1/16 of an inch. So you're supposed to pull out a ruler, slap it on there, and give that measurement. Remember, sometimes with those rulers, guys, it doesn't start all the way at the end. Sometimes it's a little bit in, so you've got to find that 0 on your ruler, place it on there, and then count your little tick marks to get there, and in many cases you have to reduce those things. So if I was looking at AB and I put my inch ruler on here, I'd get about 7/8 of an inch. If I was looking at BC, now I have to slide my inch ruler so that the start is on the B and I'm measuring to the C. And if I did that, I would see that BC is about 1 5/8 inches. And in this case, if I was going to try to figure out what AC was, I would just add those two together and go the whole way. Now, I said add those together. You could certainly do that. 7 + 5 is 12/8. I'd have to reduce that down. Maybe you just want to do it with measurement. Put it on here, put it together. That should give you 2 1/2 inches. Any way you can look at that. Don't forget your labels when you're doing measurements. Working with the rulers that are there. Lots of times in your book, they'll give you the ruler and ask you. Sometimes they'll ask you to draw those things. Between example 4 and 5 says this. Just as we have used the number line to order integers, we can use a number line to help us order fractions. Arrange these fractions in order from least to greatest. Okay, I'm going back over here to this inch ruler and I'm just going to look down the line. Which one comes first? 1/4. So I write down 1/4. Which one comes next? 7/16. Then 1/2. And finally 5/8. So if I'm not good at fractions yet, I'm going to use my inch ruler and get my answer. The other skill that they want you to have is saying, hey, this is a half, less than a half, less than a half, more than a half, and then you'd have to decide those. If I'm good at finding common denominators, 8/16, 4/16, 10/16, and 7/16, and then I just put my numerators in order. 4/16, 7/16, 8/16, 10/16, and then they reduce that back down. This is a lot of math work. This is easy on a ruler. Page 56 is a real blessing. Okay, that gets us through the lesson. You have a good practice set on the next 2 pages. Feel free to look at those, glance at those, work some of those. Make sure you're doing your work and showing your work on that back side of that math power-up sheet so that you are practicing doing these problems as we work our way through that. Remember, there's no shortcuts. The work I put in is the work that I'm going to get out, and we'll get going on our practice 8 problem set. 6, we're ready for our practice set for lesson 8. We're starting with number 4 today. It says list the single-digit divisors of 1280. And so that would look, I'm sorry, I said 12, 1680. So I'm going to write 1680 down, and then I like to add those things right together. 1 + 6 is 7, + 8 is 15. That's going to help me with the 3 and the 9. Now I got to list everything that's divisible by it. 1 goes into everything, don't ever forget that one. I look at the last number, it's 0, it's even, so 2 goes into it. I look at the 15, divide by 3, it works, goes in there 5 times, so 3 will go into that. To do 4, I look at the last 2 numbers. 4 goes into 80 evenly 20 times, so 4 is in it. I look at this 0 again, I know 5 goes into it because it ends in 5 or 0. 2 and 3 are there, so 6 is into it. 7, remember, I have to do the work. Now, I don't know about you, but I'm going to look at 1,680 and say, nope, definitely not. Doesn't look like a 7 to me. There's no saying it doesn't look. We have to do the math. So I go in there, 2 gives me a 24, 28. Oh, thank goodness I did the math. Yep, it goes in there evenly. Yes, 7 is there. Remember, for 8, it's the last 3 digits. So I do 680 divided by 8. It saves me 1 step in math.
It goes in there 8 times. That's a 64. I subtract, bring down the 40. Yep, goes in there 5 times. 8's on the list. Look at my 15 again. 9 does not go into 15, so 9's not there. So you check that list out. All of them but the number 9. Next one, example 5. It says point A represents what mixed number on the number line? So the first thing I'm going to do, guys, I'm going to count those spaces with you. I'll quick draw this out. I have a 3 here, and then 1, 2, 3, 4 tick marks, and then the 4, and the point is here with an A. Now remember, I don't count tick marks, I count spaces. So 1, 2, 3, 4. There are 5 spaces between them. Now I count the lines, 1, 2, 3. It's on the 4th one, and then I don't forget my whole number. So what line is represented? 3 4/5. Number 7 says, please use words to write this big number. So the first thing I do is I count how many zeros there are, and I start adding my commas. So I counted all those zeros, and I got 8 zeros. So when I add the commas, it would look like this. And now I just break it into pieces. So the first number is 32. Don't forget your hyphen. And that's in the billions position. So 32 billion, comma. Then the next 3 numbers, that's the number 500. And it's in the millions. And the rest of them are all zeros, so they don't matter. So my answer is 32,500,000,000. So make sure you are adding your zeros for that one. Number 8, what fraction of the circle is shaded? Sorry, wrong button there. What fraction of the circle is shaded? You can see it's divided into eighths. And they have 1, 2, 3. So the first thing is 3/8 are shaded. The second question is what fraction of the circle is not shaded? That would be counted over here. 1, 2, 3, 4, 5. Some of you who are good at math quickly might have just subtracted 8 minus 3 to get the 5. Number 9, what percent of the rectangle is shaded? I'm going to just do this one right on this problem. You can see it's divided into fifths, and they have the bottom one shaded. Okay, if you remember the math, guys, percent always means 100. How many is it divided into? It's divided into 5, so that goes in there 20%. I then multiply by my numerator, which is 1/5. 1 times 20 is 20%. Okay, that's A. What percent of the rectangle is shaded? Now you got 2 choices for B. You could say, hey, 4/5 is unshaded, so I'm just going to take 4 times 20 and get 80%. Or you could subtract 100 minus 20 to get 80%. So A, 20% is shaded. B, 80% is not shaded. Number 10, what is the name of the part of the fraction that indicates the number of equal parts in a whole? If you're looking at your yellow folder for the answer, you got the bottom number. That is called my denominator. And you just have to write that answer down. Number 12, B plus 225/48 equals 60. Missing something in addition, I subtract. So I got 60 minus 25, 48. And it is money. So I cross out the 60, I make it a 59. That becomes a 10 and a 9, that becomes a 10 and a 9. I'm sorry, that does not become a 9, that stays a 10. 10 minus 8 is 2, 9 minus 4 is 5, decimal point straight down, 9 minus 5 is 4, 5 minus 2 is 3, and I get an answer of $34.52. Number 15. E over 15 equals 15, missing the divisor, so I'm going to multiply. I said divisor. I'm missing the dividend, so I have to multiply. That's 25, that's 7, 5, 1, get a 5, get a 12, carry the 1, get 225. Should be memorized. 15 squared, 225. Flipping your answer key over to number 16. This time, I'm missing the divisor. When I'm missing the divisor, I still divide. 14 into 196 goes in there once, gives me a 14. Subtract 56, goes in there 14 is 56. Notice your perfect squares. So your answer is 14. but you should keep working on memorizing those perfect squares. Number 17, it says give the reasons for each of the first two steps to solve it. 8, 9 plus n plus 8 equals 20, and the first thing they have is n plus 8 in parentheses. Now I move down and I have 9 plus 8 plus n equals 20, and they put this in parentheses. Notice the same number letters, different order. That's the commutative property smashed onto your screen so you can't see it. Then they did 9 plus 8 plus n equals 20, and they switched groupings. When you switch groupings, that's the associative property. So they keep giving us problems with that to make sure we have that. Number 20, an addition problem, 3,625 plus 431 plus 687. Adding those all together, and I have 5 plus 1 is 6 plus 7 is 13. Carry the 1. 1, 2 is 3. 3 plus 3 is 6. 6 plus 8 is 14. Carry the 1. 1 and 6 is 7. 7 and 4 is 11. 11 and 6 is 17. Carry the 1. 1 and 3 is 4. I have 4,743. Number 24 is a division problem. I have 3,456 being divided by 6. 6 goes into 34 5 times. That gives me a 30. Subtract 4, bring down the 5. 6 goes into 45 7 times. That gives me a 42. Subtract 3, bring down is 6. 6 into 36 is 6 times. 576 for number 24. Here comes 26. It says the rule of the following sequence is k equals 3n minus 1. What is the 10th term in the sequence? So k equals 3n minus 1. Now they say stick 10 in for that. Letter next to a number means multiply. So 3 times 10 equals 30 minus the 1 equals 29. That's the 10th term. B says, what pattern do you recognize in this sequence? They gave me 2, they gave me 5, they gave me 8, they gave me 11. The sequence is add 3. Number 28, it says name an acute, obtuse, and right angle. Okay, so the first one I'm going to do is A. Name an acute angle. Well, guys, I can do that with just one letter. That's the letter B. That's acute. Then it said name an obtuse angle. I can do that with one letter as well. That's letter A. That's obtuse. Remember, B less than 90, A obtuse greater than 90. And then they said name your right angles. They always have the square, so that's angle C and angle D. Don't forget your angle signs so that we know it's an angle. You could have named them with 3 letters if you want, but because there's no confusion, because there's just one angle out of each letter, you could do it with just one. And number 30, referring to the figure below, what is the difference in meaning between the notation QR with a line and QR? The difference is this is naming a segment, This is measuring. That's measuring the segment. So if there's a line, we're just saying, hey, this is QR, that segment we're talking about. If there's no line above it, then we have to measure it. Sometimes, guys, remember from the lesson, they put an M in front of it, and they want you to measure it. But that's just the difference between those things. That'll come up later on in a test, too, where you have to name those segments. Make sure you have the measuring of those things to make sure you get them. All right, our 15 problems. You want extra credit? Feel free to do the next 15. We're getting closer to our first test coming up this week. Bless